Hello, I'm Angus Thompson from the Australian Institute of Marine Science. Please stay with me as I give a summary of the state of inshore coral reefs on the Great Barrier Reef following surveys in 2020 by the Great Barrier Reef Marine Monitoring Program and the Australian Institute of Marine Science's long-term monitoring program. Central to our reason for monitoring these reefs is that there's multiple pressures that influence their condition. These range from natural climate events such as cyclones and large rainfall events, through to the sort of socio-economic pressures which govern the way that we interact with the environment, both in the catchment, and that ultimately ends up in changing runoff coming out and influencing the coastal waters, but through to global effects such as climate change and also direct use from tourism and fishing and the like. The Marine Monitoring Program is really all about monitoring the state of these inshore reefs to send that message back through to management bodies to potentially alter the way that we interact with the environment and the catchments. And really at the crux of this is ensuring that the reefs remain resilient. And this is central to the desired outcome from the Reef 2050 Water Quality Protection Plan, which really states about building resilience and improving ecosystem health through the maintenance or improvement of water quality. And to give you a summary of what we're talking about in terms of resilience, coral cover on reefs is naturally variable as impacts such as acute cyclones knock down coral cover, and then it goes through a period of recovery until declining again in another disturbance. And if pressures are light, the red arrow on the right, then that recovery potential can sort of keep track and keep in long-term balance with the disturbance regime. The concern is that as pressures increase, so runoff potentially, climate change, all these things, then that suppresses that recovery potential, or in fact creates additional acute disturbance events like mass bleaching events. And so you can get a ratcheting down, you never get back to that full recovery. Quick outline of what we're going to cover. We're going to cover what and where we monitor, set the scene for interpreting results in the context of recent disturbances. Obviously, to tease out the effects of water quality, we need to understand the effects of things like cyclones and Crownathon starfish. Summarise the impacts of the coral bleaching that occurred in early 2020 as the most recent large-scale event to influence the reef. And then cover off on some trends in primary indicators and look at how the resilience varies in relation to environmental conditions. And this is really how the index, which is the sum of the indicators, and I'll cover that shortly, changes due to runoff. Where we monitor adjacent to 4 NRM regions along the coast. In the wet tropics, these surveys run from up at Snapper Island off the Daintree through to down around Mission Beach. In the Burdekin region, we're really between Magnetic Island and the Palm Island group. In the Whitsundays, we monitor all through the Whitsunday Island group. And then in the Fitzroy region, we're down in Keppel Bay. Our monitoring is all done from small boats. We do this to ensure that we can take advantage of calm weather windows, not quite as calm as this usually, and that allows us to have the best chance of actually seeing what we're doing on these often turbid inshore reefs. We do 3 different surveys when we're out. The first one is as we're running out the transect shapes, we're doing a scan of the bottom, looking for anything that's damaging corals. In this instance, we'd be noting coral bleaching, but there may be disease, Crownathon starfish, Drapella, which are both eating the corals, or a lot of breakage from a recent cyclone. Once that tape's run through on our permanent markers, we come along and we take photos of the bottom, and this gives us, we take these images back to the lab and analyse them for percent cover of benthos, coral, algae, sediment, noting that these are permanent markers that we have down there so that this transect is in the same place from one year to the next. Finally, we come back along these transects and count juvenile corals. These are the corals less than 5 centimetres in diameter, and that gives us an idea of how that recovery potential is going. From these data, we score 5 indicators, and I won't dwell on these, I'll just state what they are. But the 5 indicators then get wound up, averaged, and they're the results that go into the regional and state level reef report cards. Indicators are coral cover, juvenile corals and the density of those, macroalgae being the proportion of macroalgae to other algae, the rate that corals are increasing, and community composition. Now, to summarise the recent disturbance histories, this is just cyclones over the last decade. You can see on the panel on the right, there has been very little impact in the reefs over the last 3 years. Some very small cyclones which really caused no damage. Prior to that, we had a few big cyclones that came through, notably Cyclone Debbie, which is in the kind of salmony coloured one in the central, in the middle panel there, really damaged reefs in the Whitsundays. And then Cyclone Yasi was a very damaging cyclone in some of the wet tropics and vertical reefs in the purple on the left-hand panel. Another pressure that's been building is high water temperatures, which cause coral bleaching. On this panel, you can see the last 5 years of temperature anomalies over summer. The degree heating weeks measures the anomaly above the maximum summer temperature for any location along the reef. And you can see in 2016 and 17, there was quite high anomalies up in the northern parts of the reef. And if you're looking at this scale, anything in the sort of yellow to oranges is going to cause bleaching, and anything once you get into the reds or above, you're really expecting both bleaching and mortality of corals. And so you can see there was some bleaching, some high anomalies in the wet tropics through to the Vertican region in 2017, and then quite coastally along the Vertican lower wet tropics in 2020, and also down through the Whitsundays and into the Keppels. But you can see there is a slightly cooler little patch of orange just around the Whitsunday Islands. And finally, then there's river discharge. When we've been monitoring, we started back in 2005, and you can see that 2003, 4, 5, 6, it was quite dry, and in fact it was dry for a couple of years prior to that also. So we came in at the end of a drought, which means there had been limited discharge into the river, into the reef, so lower loads of sediments and nutrients at that point. Then we had a period of very high rainfall, and particularly in the Burdekin, also in the wet tropics, in the Mackay Whitsunday and Fitzroy region. Not so much in the wet tropics, but definitely a little bit above average. And then more recently, we've had a period of slightly drier conditions that are again, so we've seen this very distinct change in the loads of sediments and nutrients just due to the difference in rainfall. And also there's Crownathon starfish. These have only really been recorded on the inshore reefs during our surveys up in the Cairns sort of regions and Innisfail, between Innisfail and Cairns. And you can see that in 2020, 5 of the 6 locations we surveyed had densities of Crownathons that were above outbreak levels. That's that red line. But these were small. And so the damage they were causing, although they were there and feeding, because they were small, they weren't having a huge impact on coral cover at the point of survey. This plot gives a summary of the losses of coral that we've seen over the period of the program and breaks it down by disturbance type. So here, a value of 6%, that's 6% coral cover loss. So it might have been, if the average over all reefs was say 30%, this means that it would have dropped to 24% over that period. So it's not a proportion of 30, it's an actual loss of percent cover. You can see that storms have accounted for almost 50% of the loss of corals we see. So they are a really damaging influence to inshore reefs. On top of those, the bleaching impacts have been building, and you can see the red in the last few years, those bleaching events have come through there, but there was also quite a severe one in 2006 down in the Keppels. The next two, the chronic and disease, these are really what we're thinking are the signatures of the pressures associated with the environmental conditions. So this is the corals are not growing, slightly going backwards. And a lot of this sort of occurred in that wetter period. You can see those orange marks on top of those plots, sort of from 2009 through to 2014. And then COTS, obviously, we don't get too many. And floods, this is only when actual fresh water hits the reef, and that occurred down in the Keppels in 2011. We lost quite a lot of coral on the shallow reefs due to exposure to freshwater plumes. Looking at the bleaching response over 2016, 17 and 20, those hot years I showed earlier, we can see that in 2016 we didn't really have the heat anomaly, so we didn't get so much bleaching. Around the Tully-Burdekin region in 2017, we got some bleaching. And then in 2020, quite a lot of bleaching in the Burdekin and Fitzroy, not so much the Whitsundays. If I recall, I said it was a little bit cooler there, but also, in addition to being cooler, those surveys were later in the year, and so we could well have seen a fair bit of recovery, but I think just the mixing in that area limits the bleaching as well. So to get a handle on what we see out there, this was Orpheus Island on the outside of the sort of clearest water reef in the Burdekin region during the time of bleaching. It was really unbleached, looking really good. But we come just a few kilometres inshore, and this is Havana Island. Corals are clearly bleached. You can see some ongoing mortality, those pale patches in amongst the dead coral there and the bleached coral, noting that a lot of this will hopefully recover. And then once we come right inshore into Jeffrey Bay, it was extensively bleached, and we'll see the full ramifications of that when we survey again in 2021. Looking at this bleaching response and possible drivers of it, obviously when we look at degree heating days, the 2017 event was actually higher degree heating days, but we saw a little bit less bleaching. So that's an interesting result. Certainly in the central sections, Tully and Burdekin and the Whitsundays, again, we didn't see any evidence of bleaching the Whitsundays that year because most of the corals had been killed by Cyclone Debbie. And then in 2020, we did see some high degree heating day events, especially down in the Fitzroy region was the hottest. It was a little bit less solar radiation hitting the substrates in the Whitsunday region last year, so that potentially could influence the result of lower bleaching, the turbidity just reducing the light intensity, which goes hand in hand with temperature and causing the bleaching. But also chlorophyll levels were a little bit lower in the Whitsundays compared to certainly the Fitzroy and some reefs in the Burdekin region. So potentially the slightly lower nutrients there might have also protected those corals a little. Looking at the trends in indicators, the mean line over the period of our surveys is just that dotted dashed red line through the middle. You can see at the beginning of the surveys when we started, coral cover was a bit above the long-term average, but it's come back to that average condition in 2020. And this interesting point, I guess, is the crown of thorns state in the Johnson-Russell-Mulgrave subregion, where coral cover has increased quite substantially despite those crown of thorns being present. And of course, the lowest cover at the moment is in the Proserpine, which is the Mackay-Whitsunday region, which is still the result of Cyclone Debbie. The reason, as I mentioned before, that these crown of thorns have not really had a big impact on coral cover is that they're small. These are a couple of our transect photos, and you can see crown of thorns in these photos buried deep down in amongst underneath these fast-growing acropora. So although they're eating the coral down below, the coral above is growing quite fast and sort of maintaining that coral cover from the photo transects. If these are allowed to get bigger and grow into large adult starfish, they'll undoubtedly overwhelm the growth of the corals and start reducing coral cover. The cover change indicator is an interesting one because this measures how fast corals are growing in between surveys and not accounting, and this discounts all those instances where there's a disturbance event. So this is just when your coral should be recovering, and we can see that that was sort of above that 0.5, which is the expected rate for the first couple of years when it was dry. As it got wetter, we reduced and lost. The recovery rate really declined, and then as it started to dry off again, we're getting those good recovery rates again in most regions. And this is just to give you an idea about what a good recovery rate is. This is High Island after, in 2011, after Cyclone Yasi and floods of the Russell Mulgrave. There was very little coral cover. Some of the corals that were left were broken and then had disease go through them. 9 years later, in 2020, it was looking fantastic. There was really high coral cover and it really recovered well. That slow recovery, you may have noticed, the Proserpine region, which is the Mackay Whitsundays, was the lowest, and following Cyclone Debbie, there's been little recovery of the corals there. So this is Double Cone Island just before the cyclone, and then 4 years later, it's there's been no recovery of coral cover at all at that 2 metre depth. Rather, it's turned to macroalgae. Speaking of macroalgae, this is the macroalgae indicator. Long-term average, it's been fairly stable across at the whole of the inshore scale. You can see a notable decline in 2011, and this was really due to the stripping of algae in the wet tropics and Fitzroy regions due to both Cyclone Yasi, but also flooding that directly killed the algae down in the Keppels. But notably, in both those instances, the algae cover bounced right back. So although the algae was removed, it could rapidly recover. I'm just looking at some of the algal communities that we see on these inshore reefs. Up around Snapper Island, there's quite high cover of algae, but this is sort of some greens, a halimeda in there, and then those other little algae you can see around are a mix of brown algae and red algae. Once we get to places like Jeffrey Bay, we have big stands of the very persistent Sargassum. This has been like this pretty much for the whole 16 years of our surveys. And then down further south, we get a lot of reefs that have this high cover of lebophyra algae, which are a flat fan sort of shaped algae. But you can see that in amongst these algae, we are getting a bit of recruitment of coral starting down there. Looking at juvenile corals, we saw this again has been reasonably flat. We saw a loss, and this is the density of juveniles. So we did see a loss when we lost a lot of coral cover because they really hadn't had a chance to colonize that newly exposed substrate. Then after the cyclones, you can see a real peak in juvenile densities, and this was really due to turbinaria coming in high numbers on some reefs, especially through the wet tropics and some of the Burdekin reefs. But those big cohorts have sort of died down a bit, and we're coming back around just average levels. So how does this all sum up? When we look at the coral index, so that's the mean condition based on those 5 indicators, and we look at how that changes during periods when the reefs are not being exposed to a disturbance event, so when they're in a recovery cycle, so we're expecting this coral index to improve because the coral communities are recovering. We can see that in 3 of the 4 regions, there's a decline and a statistically detectable decline in that rate of change in the coral index with discharge from the river. So if you've got more loads of sediments and nutrients coming in, you're getting a slower recovery of coral communities. And so the plots are looking just at discharge, but of course discharge, total nitrogen, total phosphorus, and total suspended solids are all related to that discharge, and so they all have similar negative relationships. But we can also, when we look at reef level, so that's just at the end of catchment, those loads, When we look at the reef level, over on the right there, the chlorophyll and total suspended solids, they're measured at the reef, estimated from satellite imagery. We can see that they also have a negative influence on the recovery of coral communities. And then finally, when we come and look at just the state of play in 2020, when we look at coral cover and macroalgae scores, both these decline with increasing chlorophyll, so we get less coral cover as chlorophyll goes up and more macroalgae cover as chlorophyll goes up. So we get that switch between coral and algae around chlorophyll nutrient levels. So in summary, cyclones continue to be the primary cause of coral loss on these inshore reefs. Inshore reefs have been kind of lucky to escape severe loss of coral due to recent bleaching events. It's been hot, but it hasn't quite ticked over to large-scale mortality. Crownathon starfish are really limited to those wet tropics reefs, and up there, culling has probably really helped to mitigate the impact. So when we've seen high numbers of cots up there, they've generally been small, and culling activities at Fitzroy Island and the Franklin group have really stopped those larger adults coming through and eating all the coral. And then finally, the resilience of these inshore reefs does show a decline during periods of high catchment input, but also with proximity to the coast and rivers, in that that's where the chlorophyll levels are higher, and we're getting that switch from algae to from coral to macroalgae. And finally, just the access to this information. We annually report scores through to the reef report card, and these are backed by technical reports that are available through the marine monitoring, through the Great Barrier Reef Marine Park Authority website and the Marine Monitoring Program portal there. There's up-to-date survey results and data summaries available through the AIMS website. This is reef level, so we just put up the results as soon as we process the data. And then the key observations are just reported back to the authority via email, e.g. this year, when we saw high numbers of crown of thorns, we reported that back in case there was a management response required. And finally, the MMP also contributes all this coral data through to the regional report cards to extend the knowledge of the state of inshore reefs through the catchments. And all data are managed in a sort of open access principle. AIMS provides bespoke data packages to people that require that data. Thank you.